Alright, today we're covering lesson 9.1, square roots. Okay, you need to know a few definitions to start. Good news, you don't have to write this down, you just need to follow along. A square root is a number that when multiplied by itself equals a specific number. So for example, 2 times 2 equals 4, 3 times 3 equals 8. So that number 9. Oh goodness, it's already starting. 3 times 3 equals 9, so that number 3 is your square root. It is the root of that product or that number. All right, stop laughing at me. I know what 3 times 3 is. Come on, guys.
Everybody does it sometimes.
Okay, so every positive number has how many square roots? 2. It has a positive square root and a negative square root. Let's take this number of 100, for example. Well, the square root of 100 is obviously 10, but the negative square root of 100 is also negative 10, so I can express that positive and negative 10. But how many square roots does 0 have? Only 1, okay? There can't be a negative 0 or even a positive 0. 0 doesn't have a sign, it's just 0. Okay, so in example 1, it gives me this example of a chessboard. It's a giant chessboard. And it says that to find the square root of 324. So in your notes you would write the square root of 324. And we know that it's positive because we're taking measurements. Measurements are positive. Okay? Equals approximately 18 meters. Okay? So on your homework tonight, really guys, it's original problem and answer on these problems. There is no work to show. We're just going to use our calculators. So go ahead and get out your calculators if you haven't already. Let's get familiar with where the square root button is if you're not already. The square root button is on the second row down, the second button across. You hit that square root button and you enter 324 and hit equals. Did you get 18?
Yeah.
Okay, so that's how I find the square root. Now, some of these you can do in your head. Some of these you have to actually put in your calculator because the numbers are really large. So in example 1 checkpoint, I want you to take note of what the instructions say. Find the square roots, plural, of the number. Why is this? Well, it's because it has both a positive and a negative square root. Think about it. What's in the first one? What's the square root of 16?
4.
It is 4. So 4 times 4, yes, is 16. But what about negative 4 times negative 4? What is that? It's also 16. So you see, guys, the positive and the negative solution both are true. That the square root of 16 can also be negative 4. All right, I want you to try to find the square roots of the other 3 numbers. So the square root of 64, how would I write it? Equals positive and negative 8. So that's how I'm going to say these answers, positive and negative. So I don't say plus and minus, I say positive and negative 8. Why? Because 8 times 8 is 64, but negative 8 times negative 8 is also 64. And 44, what is it? Not just 12, but positive, negative 12. And then what about 256? All right, you might have had to use your calculator on that last one. Positive and negative 16. All right, so there's your checkpoint. All right, for example 1. Now in example 2, we need to talk about approximating square roots. But before we do that, let's talk for a minute about the perfect square. The perfect square is a number that is the square of an integer. For example, what is 1 squared? 1. What's 2 squared? 4. So it's the square, it's the product, it's the answer of some number squared. Okay? So since 2 squared is 4, that means 4 is a perfect square. All right, so what is 3 squared? 9. So that means 9 is a perfect square. Does that make sense? So a number times itself equals some number. That number that it equals, that's my perfect square. So what about 16? What numbers can be multiplied by itself to equal 16? 4. So 16 is a perfect square because I can multiply some number by itself to equal that number. What's my next perfect square? 25, because 5 times 5. What's my next one?
36.
Because 6 times 6. What about my next one? 49. 7 times 7. Then 64. 81. 100. 121. 144. 169. Okay, and it just keeps going. All right, so those are just perfect squares because, again, their products can be multiplied by itself. 9 times 9, 10 times 10 to get those numbers. So how does this look in an example? Well, if I'm approximating a square root, I'm trying to find the closest perfect square that it's near. So I know that 51 is not a perfect square. However, if I'm going lower than 51, what's the next closest perfect square to 51? 50 is not a perfect square. 49. So 49 is on the low end. What perfect square is just above 51? 64. So I look at this range of numbers and I ask myself, which perfect square, 49 or 64, is 51 closest to? 49. It's only 2 units away. All right, guys, and it's never going to be like an even split. It will be closer to one than the other. Stop. Okay? So, since it's closer to 49, I'm going to say the square root of 51 is approximately 7 because the square root of 49 is 7. All right? So the approximation symbol is important here because this is not an exact answer. All right, this is a rounded answer. Square root of 51 isn't 7, but it's pretty close to 7. So now I want you to fill in what are going to be your perfect squares on either side of 93. Okay, so 93 is in the middle. What's the perfect square below it? And what's the perfect square above it? So what's the perfect square on the low end? 81, and then above it? 100. And which one is it closer to? 100. So I'm going to say the square root of 93 is approximately, what's the square root of 100? 10. And that's my answer. All right, now go ahead and do the third one. So on the low end, it's 16. On the high end, it's 25, and it's clearly closer to which one? 25. Okay, so the approximate square root of 24 is 5. Now, on your homework, you see what I have highlighted? That's actually all you're going to need to show, because I'm about to show you a shortcut on your calculators. Everybody go with the shortcut? Yes. But do you understand what we're doing here by finding the closest perfect square? Yes. Okay? All right, so now in your calculators, I want you to enter the square root of 51 and then change it to a decimal. The square root of 51 and change it to a decimal. Okay? Now I want you to round this to the nearest whole number. So use the 10th to round to the nearest whole number. So 7.1, does it round to a 7 or 8? It stays a 7. So that's why my answer is 7. Go ahead and do the next one, the square root of 93. What do you get? 9 point what?
9.64.
9.6. So because it's a 6, it rounds the 9 up to a 10. That's why my answer is 10. Square root of 24. 4.8. So the 8 rounds the 4 up to a 5. So that's how I want you to do your homework. You only have to show the highlighted portion. Tell me the square root of whatever is approximately. You must have the approximation symbol. If you write an equal symbol, I will take off points. It's not equal to. It's approximately that value. All right, so that's approximating the square root. Now I want to approximate, now not to the nearest whole number, but to the nearest tenth. So I'm going to do the same exact thing with approximation and rounding, except now I'm going to round to the nearest tenth. So I say the square root of 515 is approximately square root 515 equals, hit the S to D button, and I'm rounding now to the nearest tenth, so I have to look at the hundredths. 22.69, does that round the 6 to a 7 or keep it the same?
7.
Rounds it up to a 7. You see that? because the 9 rounds the 6 up. So approximately 22.7. Go ahead and do the other two. Find the square root and round your answer to the nearest tenth. Square root of 234 to the nearest tenth, what is it? 15.3, very good. What about the last one? 21.7. That one stayed the same, right? Because the hundredths place didn't round up. All right, so that's how I approximate to the nearest tenth. You have a section where it says to the nearest whole number, and then you have a section where it says to the nearest tenth. So that's how you would do it. Now let's talk for a minute about radical expressions. Well, a radical, we talked at the beginning of class, is a symbol that looks like this. Okay, that is a terrible radical sign. Let's try it again. Okay, there we go. Something like that. Now that's a radical sign, and a radical sign is positive unless there's a negative in front of it. Okay, so in some of your homework questions, it's going to say find the negative square root of 16, and because this negative is out here, it's going to be negative 4. But if it just says find the square root of 16, your answer is just 4. Do you see that? It's one or the other. If there's a radical there, it's one or the other. If there's no radical, that's when you're going to find that you have two answers. Okay? Let's see what this looks like. Okay, so now on these problems, I need to make a substitution and solve. I'm fine with you using your calculators once you make your substitutions. Just make sure that you enter the numbers correctly, especially if it's negative, it has to be in parentheses. Okay, so on the first one, we make our substitutions. Go ahead and plug in your values. Plug in 11 for A and plug in 5 for B. All right, so substitutions. Now, from this point, if you enter it correctly in your calculator, you can go straight to the answer. However, you need to understand the process. So look up here. 11 plus 5 squared. Do I add first or do I evaluate the exponent? Exponent. Order of operations. 5 squared is 25. 25 plus 11 is 36. Now I take the square root of 36 and get 6, and 2 times 6 is 12. Again, these two steps here are optional. However, you need to understand how I'm getting to my answer. Just simply, while I punched into my calculator and got my answer, is not good enough. You have to understand the why. All right, go ahead and make your substitutions and solve on the second one. So similar here, I make my substitutions. Do I add first or exponents? Exponents. 3 squared is 9. 9 plus 7 is 16. Take my square root and multiply, and I get 20. Okay, did you get 20? Did you get to raise your hand if you got 20? Okay, good. So now let's throw in some operations into the mix. Go ahead and make your substitutions and solve for each one of these expressions. All right, substitutions, here we go. Okay, so I substitute and solve. What'd you get for the first one?
4.
Okay, what'd you get for the second one?
2.
2. What'd you get for the third one?
21.
Okay, very good. 4, 2,
20.
and 21. Very good. Who got all 3? Good job, guys. All right, look at example 5 now. Solving equations with a square root. Before we do this, I want to switch gears just for a second. How would you solve this equation? 3a equals 12. How would you solve this? Divide everything by 3. Because what's our ultimate goal? Our goal is to get a by itself. So now let's go back to example 5. Now instead of a 3 being attached to a, an exponent is attached to my variable. So I still have to do opposite operations. So what is the opposite operation to raising a number to a power? It's taking the root of that number by the same power. So if it's raised to the second power, I take the square root. If it's raised to the third power, I take the third root or the cubed root. So the good thing for you is that all of the variables on your homework assignment will be raised to the second power. So what is the operation? It's to take the square root of that variable, and now mission accomplished. I have a by itself. But whatever I do to one side, I must do the exact same thing to the other side. So I must take the square root of 9, and that's going to be positive and negative 3. Here's why. It is positive and negative 3 because, let's go back to my original problem. Let's take the work off there for a second. What if I were to plug in 3 into the original? What's 3 squared? 3 times 3 is 9. What's negative 3 times negative 3?
9.
Also positive 9. So you see, both signs are a solution. The positive answer and the negative answer are both solutions to the equation. That's why it's positive and negative. So go ahead and do the second one now. N squared equals 25. Make sure you show your work. All right, so we take the square root of both sides, and n equals what? Positive and negative 5. Square root of 25. Now in number 3, they're switched. The y is on the other side now. Does that matter?
No.
No. I still have to do the same process, same thing. I take the square root from both sides, and y equals positive and negative 20. Well, look at the fourth one. What do you see that's different about the fourth one?
It's not a perfect square.
It's not a perfect square. This square root is not going to be an even number. That's okay. On all of these numbers, you will approximate it to the nearest tenth. So on any homework problem that's not a whole number for an answer, you will always approximate to the nearest tenth. So now just take your square root like you normally do. You write down your answer. Approximate it to the nearest tenth. All right, if I take the square root of both sides, I get positive and negative 4.5. Did you get that? Because we round to the nearest tenth. So if we put in our calculators the square root of 20, okay, 4.47, so that's 7 rounds to 4 to a 5, 4.5. All right, so now let's make it just a little more complicated. And now I'm solving with the square root, but now I see that I have coefficients, numbers attached to my variables. So the first thing I do here is I have to move everything. I take the square root last. I move everything else to the other side first. So I would divide the whole equation by what? 5. Okay, and now y squared equals 22. And now what do I do to solve for y squared, or solve for y? Yeah, square root of both sides, and y equals positive and negative, round to the nearest tenth. What will it be? 4.7. I want you to try to solve number 2 now. Try to solve number 2. On this one, we divide both sides by 0.5 first. And then we take the square root, and what did you get?
T equals positive and negative 12.7.
No.
T equals positive and negative 18.
Yeah, it actually doesn't seem like it's going to be a whole number, but it sure is positive and negative 18, because I should have got 324. All right, look at number 3 now. Okay, now this is almost like a 3-step. Because what do you think you do first? Subtract 1, and then divide everything, and then take the square root. Go ahead and try that one. So we do what to both sides first? Subtract 1 from both sides. 2a squared equals 97. Divide everything by 2. A squared equals 48.5. Boy, it would have been nice if that was 49, right? Yeah. It would have been an even answer. However, once I take the square root, it's so close to 7 that when I round to the nearest tenth, it rounds the tenth up to the whole number. But here's what's important, guys, that it's approximated, because it's not 7. It's just about 7, but it's not exactly 7. So on any question that you round on your homework tonight, make sure you use your approximation symbol. If it's a whole number, great. If not, approximate your answer to the nearest tenth. If you understand that, that's everything you need to know for 9.1.